So guys, let's look at the analysis of a 3D RC frame for the shown elevation and the plan as on the screen you can see. So I've taken a G+1 RC structure with 6 rooms, 3 bays in X direction and 2 bays in the Z direction. So I'll start the very first step in STAAD is modeling of the structure. Okay. Let's start and start. So new, give your exercise name or file name and select the location where you wish to store. Select your units as metric and then click on create. If you see over here, the model or the file is getting created. This is the GUI, graphical user interface of STAAD. Now the very first step is modeling. So modeling can be done in 2 ways, either by entering the coordinates of the nodes manually. So in this plan, if you see, I have already written few coordinates for your knowledge. So I prefer to take the top left corner as the origin for my structure. So if you look at this, this is my first node. Why is this needed? Because by taking the top left corner as origin, all other coordinates are going to be positive. That is the main reason. Okay. So let's take the first node as origin and enter all the coordinates and you'll get the nodes. If not, you can do it with the help of grid system. So with grid system, when your plan is symmetrical, in that case, grid system becomes more easier. So under geometry tab, under grids, you can see the beam grid option. So click on beam grid option. When you click on beam grid, here you get a grid which is in X and Y axis, that is front view or elevation of the structure. So to edit it, you can see on the right side dialog box, you have an option of edit. Click on edit, take your plane as XZ, and then you can increase your spacing of the grid. Okay, so it has to be around 13. So, okay, click on OK. And then if you see, this is an isometric view. So click on top view. Once we click on top view, you can start putting up your nodes first. So if you see in the picture, the first bay is of 4 meters, then 5 meters, and the third bay is for 4 meters. So I've done the same 0 to 4, 4 to 9, and 9 to 13. Similarly, in the Z direction, there are 2 bays, 4 meters and 5 meters. Let's draw the same 4 meters and then 5 meters. Again, in this direction, 4, 5, 4, then 5, and then 4. You can't overlap the beams. Okay, so you have to click on escape, click on snap node or beam, and then again the same number of nodes in the parallel lines again in the opposite direction. If you draw a continuous line, there will not be a node. Okay, so wherever there is a joint or intersection, you got to click over there, you get a node, and this becomes one beam, and this is another beam. If you draw it continuously, it becomes one single beam. And then once your plan is done, just close it, you get your plan. Now I consider this plan at the ground floor. So this is the ground floor at this. So from here, I have to copy down the same at 1.5 meters, and I have to copy the same nodes to 3 meters and 6 meters. So let's do the next step. So if you see over here, get into the front view first, select the nodes with the select node cursor, select your nodes, okay. Right click, copy, right click, paste nodes. You can copy the same at whatever uh, depth your foundation is. So here my depth of foundation is 1.5. I'm at G, going down, it becomes minus. So it becomes minus 1.5 minus 1.5 in along y-axis and then click on OK. You can see all the nodes have been developed. Similarly, if I wish to go ahead with copying the beams and nodes all together to the upper floors, select your beams and nodes, Geometry, you have this translational repeat option over here. Click on translational repeat. Select in which direction you wish to copy. How many number of steps? That's 2 steps, but at the spacing of 3 meters each. So the spacing changes. Click on link steps. You get your columns, and this is the structure. Let me show you an isometric view. This is your structure. Now getting back to the front view again, we have to connect the columns at foundation level. So select your nodes. Okay, select your nodes and then geometry. Here you see the add beam option. You have to add the beams or connect the nodes along y-axis. So click on y-axis and you get the complete structure created. I'll show you in the isometric view again. So if you see over here in the isometric view, all your nodes have been selected. Next step is to create the supports. So select the supports. Before that, get into the front view, supports slope, supports may create, fixed. You have the fixed supports all over. So click on add, select the fixed supports, select your nodes in a box selection over here like this, and assign to selected nodes, assign, and yes, you can see over here assign to selected nodes. And I'll show you in the isometric view back again. So here you see all the nodes at the foundation level have been given as fixed nodes. Once that is done, get into the properties, that is beam and column dimensions. If you see over here, prismatic, click on prismatic, and then here that goes rectangular section. You can take any section as per your number of floors and number of bays. I've taken a regular section 230 by 230 as my structure is G plus 1. So select that. You can assign it to all the beams and columns, or you can assign, you can create two different sections, one for beam, one for column, and assign the section accordingly for beams and columns. Here I'm assigning for both beams and columns. So I can directly assign to view. When I click directly assign to view, all the beams and columns become of the same section. Okay, so you can see over here of the same section, this has been assigned. Now, very important part is loading. Let's get into loading. Now, one more step. If you wish to assign two different sections, in that case, how you can do is get into select beams parallel to X, parallel to Z. This selection is for beams. Okay, and when I say parallel to Y, this is for columns. You can assign ones for columns and ones for beams. Now in this example, I have taken the same section for beam and column. Okay. Now let's get into loading, which is actually a very important part of gravity analysis of our problem solving over here. So first of all, define the load cases, dead load and live load. Click on load case details, click on add. The very first one, you can select the dead load over here. Give the title name as dead load to have a clear understanding of what that load case is. So click on add. Next load case I'm giving is it live load. So create one more load case as live load and click on add and close. Okay. Under dead load, what all things come is the dead load of the slab, self weight of the beams and columns, dead load of the walls onto the beams, internal walls, external walls. You can accordingly calculate what is the uh, load from external walls coming out of the beams and internal wall coming out of the beams, and the slab load. Okay. Next, under live load, as per IS 875 Part 2, whatever is the live load for a residential building, that one shall be applicable. So let's do one by one. Dead, add, click on add. So very first one is self weight. Self weight acts in y direction -1 because y direction is positive acting upwards. So here y direction is negative. Self weight is acting downwards. So -1. And then click on add and close. Here you see self weight has been defined. Self weight is for the every member that is represented on the screen. So assign to view, assign, and yes. Let's go for the next one. Dead load. Under dead load, add. Next one I'm talking about is wall load. Wall load is a UDL load. Wall load is a UDL load which acts onto the beams. So the wall thickness based on your thickness, 230 mm thick for external walls, 150 mm thick for internal walls. Okay, accordingly you can calculate your load. I'm going for a complete a rounded number for 230 mm thick walls. That's minus 13 kilonewton per meter. I'll put it in GY, global Y direction, and it acts downwards. So that is the reason why minus 1, minus 13. And then click on add and close. So if you see, wall load of minus 13 has been defined. Now this has to be assigned only for the beams. So select beams parallel to X, parallel to Z, and then assign to selected beams, assign, and yes. Okay, so here you can see it has been done. For the topmost story, it has to be just parapet wall, right? So the assignment has been wrong. Okay, so do not assign to the all beams. For this, we'll have to cut the structure. Let's look in the front view. Before that, I'm gonna just redefine the member load of wall load minus 13 and then click on add. Now in a window, selecting these two floors where the wall load is gonna develop and click on new view and then click on OK. So here now select beams parallel to X and parallel to Z. You can look at that in the isometric view. Only beams are being selected. Assign to selected beams, assign and yes. The wall load here has been assigned to the columns also if you see over here. And why has it is clearly visible the wall load is assigned to the columns also. So that is not a proper method of assigning. I'll show it again once again. Dead, add, member load minus 13 in GY direction, add, close, and then select beams parallel to X, select beams parallel to Z. Now, this is the proper way. Assign to selected beams, assign, and yes. Now you see the columns are not loaded. So when you load the wall load, it has to be only onto the beams. Now how to get the whole structure? You can click on view and you can see display whole structure. Now you see the wall load is put only for the ground floor and the first floor. Now let's put parapet wall load onto the topmost. And now again with a window, okay, select only the top floor, click on new view, click on OK, and then look it in the isometric view. It's just the topmost floor. Now again dead, add. Similarly again member load minus 2 for parapet wall, add and close. You can select the members either with the help of box selection and pressing on the control. Okay, the end beams where the parapet wall load will be transferred. Select the load, assign to selected beams, assign, and yes, done. Now you can see it in the isometric view. The parapet wall load has been done. Let's look at the complete structure. Now this is the parapet wall, this is the wall load of regular thickness. Okay, now after which we have to give slab load. The slab load will be given as floor load. Click on add floor load. Floor load is a load which is present throughout the floor, and the pressure of floor load, if the slab thickness is 120 mm thick, so 120 into density 0.12 into density of concrete, RCC 25, and then you can consider 1 to 1.5 kilonewton per meter square as flow finish and other things. Okay, So in total, it comes out to be 4. So it has to be again minus 4 because acting vertically downward and y is positive upwards. So minus 4. Minus 4, and then here the ranges. Here the ranges define from what range to what range you wish to apply the load. So if you see, look at our figure. This is ground level G, and this is 3 meters, this is 3 meters. So we have a slab at this particular level, this particular level, and this particular level. So the ranges minimum starts from 0 to 6. 0 to 6. X range and Z range, even if you don't define, that will be applicable throughout the structure. And then you can add and close. So this is not needed to assign, it will be assigned automatically. So if you look from the top, um, this is a perfect two-way slab. Even this is a two-way slab. Even this is a two-way slab. The other three slabs are one-way slabs and accordingly shows the load distribution as per the E-line theory. For the two-way slabs, all the four beams are given with the triangular load distribution, whereas for one-way, for all the slabs over here are two-way slabs. Okay, for rectangular two-way slabs, triangles onto the shorter beams and trapezoidal onto the longer beams. And for one-way slabs, half of the load goes onto the each longer beam. That is how it's done. Now let's talk about live load again. Uh, in live load, as per IS 875 Part 2, the live load is -2 for any residential building. Minus because it acts vertically downward, -2. Again, the range goes from 0 to 6. Add and close. And then when this is not needed to assign, that has been assigned beautifully on all the floors. Now let's add the combination. Load case details, add. Here you can see the defined combination. Um, Factor of safety is 1.5. You can take both as 1.5, add and close. Once this is done, get into analysis, click on define commands, and then no print command, add. So we got to get a command over here with perform analysis, and then once this is done, get into click on run, save your file, and it gets analyzed. So it took around 1 second to analyze. If you have any error, it will be shown over here, and then click on done. Okay, this is how analysis of a RC structure is done. For looking at the results, you can get into post processing. You can click on apply and then OK. Here you see already displacement figure is on, so you can switch it off and you can switch on your Fy, axial force, and then bending moment. Increase the scale, you can click on scale over here and you can increase the scale. So this is bending along Z. So by increasing its, so now you see the scale of bending moment is clearly visible. If you wish to look in the front view, okay, this is for load 2. Load 2, which is live. I need it for combination. So click on combination and select that, and accordingly you can reduce your scale. Okay, accordingly you can reduce your scale. You can look at your reactions. Okay, then beam results. These are the beam results for dead, live, and combination. What is the reaction? What is the moment about that axis? And that's all. Okay, this completes analysis of the RC frame structure.